Okay, so for the x direction, if you substitute in the acceleration into our three equations of motion, you get the equations of motion for the x direction. Same thing, the equations of motion for the y direction. And now we can look at a couple of different projections. So a horizontal projectile, and this is a very common question. So this is horizontal. The horizontal projectile. So imagine here's my cliff of science, and here we go. We're going to shoot something, whoa, straight off the edge of the cliff there. So the initial velocity is horizontal. Is it moving in the x direction, y direction, or both initially? Only in the x direction. So what is the initial velocity in the y direction? 0. What is the initial velocity in the x direction? V0. Whatever the initial velocity is. So if that cup slides off the table at 2 meters per second, the initial velocity in the x direction is 2 meters per second. The initial velocity in the y direction was 0. Now, if you follow the trajectory, the fancy word for the path of your projectile, it'll hit the ground over here. And when it does, it is moving. It has a speed that is x direction, y direction, or both? Both. Oh my goodness. All right. So look, the velocity in the x direction, does it change? The velocity in the x direction is the same, the same the whole time, because is there an acceleration in the x direction? No way. Okay, what happens to the velocity in the y direction? It increases, and it increases in the negative direction, so it gets to going faster and faster and faster. Whoops. Okay? Until it's moving both in the x direction and the y direction when it hits the ground. So let's look at that. So when it hits the ground, it's moving over, and it is moving down simultaneously at the same time. Simultaneously, right? So could you find its resultant speed? So you'd have this velocity in the x direction because it's the same as the initial velocity. Did it change? No. Could you solve for the velocity in the y direction? Sure. So could you get this resultant speed? I'm going to call it VR for resultant, R for resultant, speed, resultant. See what I did there? All right. And then we've got an angle because it's not going to hit the ground going straight down or straight over. It's going to hit the ground going down and over. So if I have basically the base and the height of this triangle, how do I find the resultant? Oh, Pythagorean theorem. So VR would be equal to the square root, is that how that works? Of the x component squared plus the y component squared? Sure. So that would be your resultant speed. So the resultant velocity, or sometimes it's called speed, the speed that it hits the ground with. So if a question reads, the speed that the projectile strikes the ground with is 6 meters per second, that is the hypotenuse. Okay, you've been given the result. You've got the x and the y component together. All right, you'd have to separate them back out to find the x's and the y separately. All right, now what about this angle? Could you solve for the angle right there if you had the Vx and the Vy? What would you use? You'd use tan, and to get the angle out, we need to use the inverse tan. Does that seem familiar to you geometry folks? So you have the y component, the opposite component, over the adjacent component, and that would give you the angle that it strikes the ground.